So last time we were doing coordinate systems, you were drawing your triangle on a coordinate system. If you're talking coordinates, then we want to use x's, y's, and r's. Okay, this is talking geometry, and they want you to just do a normal, regular old triangle. Actually, I should have done it that way. Yes. It is. All right. So, okay. We're talking right triangle trig. When you talk trig, gentlemen, can we end it and move on here? When you're talking trig on a coordinate, not on a coordinate system, it's just out in the plane, then we label our triangles with normal alphabetic letters. When you're on a coordinate system, we use Greek letters. So if you're seeing Greek letters, you're talking a coordinate system. If you're seeing regular letters, you're just talking a triangle in the plane. Okay, when we label them A, B, C, C is always the right angle. That's just an assumed thing that everybody knows. If you're going to have A, B, C, C is going to be the right angle.
Wait, how do I do these in Japan?
I don't know. Okay, and we hopefully know that you always label sides with the letter opposite the angle. So if you have angle A, side A is opposite it. Angle B, side B is opposite it. And sides are always done in lowercase letters. Okay, we're good with that. So therefore, this is why the Pythagorean Theorem works as a squared plus b squared equals c squared. If you keep angle C as the right angle, then side C is always the hypotenuse. Okay, but I actually don't want to do that. What I want to do is I want to do what are the ratios of the trig functions in this situation. How do you know? We could try to translate this back to sine is y over r, but you all learned another saying for doing it this way? Yes, you learned Oscar had a heap of apples, and what did those letters stand for? Yes. This was the opposite side over the hypotenuse. What was A? The adjacent side over the hypotenuse, or opposite over adjacent. Okay, when we work with triangles like this, we do everything with sine, cosine, and tangent. You don't need secant, cosecant, cotangent. You can solve anything you need out of this with the three primary functions. So that's why in geometry you didn't learn secant, cosecant, cotangent. There's no need for them with those kind of problems. So you'll only need to know these three. Now, did anybody learn SOHCAHTOA? Okay. Some textbooks, some teachers teach it as SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that's another option for remembering it. No, for these kind of problems you won't need to use those. Okay, so basics here. Let me draw you a triangle. Ooh, that was bad. That was so bad. Try again. There we go, that's better. Suppose I told you that you have a right triangle here, right angles up at the top. It's an 8, 15, 17 right triangle. And so if I say to you, we need angles A, B, and C on it, of course. If I say to you, what's the sine of angle A, how do you find the sine of angle A in that picture? Yeah, the opposite side over the hypotenuse. So opposite would be 15 over hypotenuse, which would be 17. Okay. Do you get the same thing if I ask you for the sine of angle B? Because now, what's opposite angle B? Okay. And this is one of the reasons it's really important you always put an angle with your trig function. Okay. Sine of angle C This is only defined for the acute angles in a triangle. It is not defined for the right angle. You don't use Oscar here on the right angle.
So there will never be a sine.
There won't be a sine of C for in these type of problems. You won't do a sine of C.
Is there though?
Yes. We'll get to it here shortly. Yeah.
Or
Okay.
there isn't.
Now, I'm looking for you to notice a pattern here. What's the cosine of angle A?
8 over 7.
So, what side? How do you find the adjacent side anyhow?
Side
So the side that touches A.
It touches A, but it's not the hypotenuse. So the side touching angle A that's not the hypotenuse is 8 over the hypotenuse of 17. So what's the cosine of angle B? Okay, do you notice anything in common here?
They're all cosine B are the same.
Yeah. The sine of A and the cosine of angle B are the exact same value. And the cosine of A and the sine of B are the exact same value. Okay? What's the relationship between angles A and B, size-wise? They add up to 90, don't they? I mean, they wouldn't necessarily both be 45s, but don't angle A and B have to add up to 90?
Yeah.
What do you call angles that add up to 90?
Complementary.
They are complementary angles. Okay, Devin, you might want to catch this. This is like the whole reason we name these trig functions the way we name them. A and B are complementary. So this is sine and complementary sine. Cosine, the cos is short for complementary. Sine and complementary sine. So therefore we have secant and complementary secant. Tangent and complementary tangent.
Okay, so let's take it deeper.
So therefore, if I tell you what the sine of 30 degrees is, it's the same thing as the cosine of what angle? 60, because they're complementary. So the sine of 30 degrees is the same thing as the cosine of 60.
Then it's tangent?
Yeah, so suppose I gave you the tangent of 1 degree. It's going to be equal to the what trig function? The cotangent of 89 degrees. And same type of thing, if I gave you the secant of 22 degrees, it would be the same thing as the cosecant of 90 minus 22, which would be 68. Yeah. So that's actually how they got their names, sine and complementary sine, tangent, complementary tangent. So, it makes sense why they named them, at least that part. Now, why they pick sine, I don't know what Latin sine means, so I don't know why they picked those particular names, but
So tangent, secant, and sine are the base ones.
yeah, tangent, secant, and sine are the base ones. So I believe on your journal, did I ask you to write, these are called the co-function relationships, it's short for complementary functions. Did I ask you to write the co-functions?
Yeah, 3 cofunction relations.
Yeah, okay. Co-functions, it's short for complementary functions. So what I'm asking you therefore is, if you know the sine of angle A, you know it equals the cosine of what?
Angle B.
And I don't want to say angle B though. How do I calculate it from it? If I know angle A, how do I figure out what?
90 minus.
There we go. You would say it's 90 minus angle A. It's the complementary angle. And therefore the tangent of angle A is equal to the cotangent of 90 minus that angle, the complementary angle. And same way with secant.
Yes, like all these.
Yes, all 3 of those on your journal. Yep.
I'm not just for you.
Yeah, there's just the 3. So that's kind of handy on occasion if you know. In fact, it's going to explain our special angle values we're going to do here shortly.
But this only counts for a right angle triangle.
This only counts if you're in a right triangle, yes. You have to be working with a right triangle. We will later, toward the end probably late March, early April, then we'll do all kinds of triangles that aren't right triangles. How you solve and find missing angles and stuff when you're in triangles that don't have a right angle.
You can't.
Yo, no, there's what's called the law of sines and the law of cosines. They'll solve anything.
Or there's a law.
Anything?
You might have learned law of sines in geometry.
I think we did.
'Cause it's actually pretty simple, too. And
It's not the big long formula things for it.
it's a law of cosines is big and long, if you learned it. That's one of those things that he does if he has time, and sometimes he doesn't get it all of them covered. Kind of depends on how much time you got. Okay, so can I switch screens? Where my time was? Okay. No one's saying I can't switch screens. I'm drawing you a picture then. So this is a snowdrift. A couple years ago. Okay. This is Ernie. Ernie loves to stand on top of snowdrifts.
Is that a horse or a deer or is that a dog?
That's my dog.
It looks like
Oh, no.
Okay.
I'm not gonna lie, it actually looks half decent.
I don't know if I call that half decent. Okay. So Ernie's standing on the snowdrift, looking down over here at Zeus. Nope. Zeus is a cat.
You have a cat?
named Zeus.
Wow. I hate cats. You too.
I live on a farm. You have cats or you have other critters.
That's a good point.
So I've had a cat.
You ever got any coons running around?
Have I had critters running around? Not coons. Not too much. Not with Ernie around. They don't come to the house.
Is Ernie a coon dog?
No. I've had possums in my backyard, but I haven't ever had a coon to my knowledge.
Kick the possum.
All right. So Ernie's standing on the snowdrift here, and we know that if I come straight down, distance from Ernie to Zeus is 32 feet.
We're doing angles of elevation, aren't we?
Yeah, baby. Okay. I want to know what is the angle of depression Actually, I need to give you one more piece of information. What is the angle of depression? Oh, whoa, I lied. The angle of depression, we know the angle of depression. Whoops, sorry. The angle of depression from Ernie to Zeus is 18 degrees. Did that wrong.
So we're trying to find height?
Yes. So the angle of depression from Ernie to Zeus, this is E for Ernie, Z for Zeus, is 18 degrees. How high is Ernie?
5 feet.
Okay, my question to you is, we've done this before, you did in geometry, where is an angle of depression located?
Below the x-axis, right?
Below the straight line.
If you come straight out, angles of depression have to go down from a horizontal line.
Yeah. Would I be right in saying that it's below the x-axis?
Well, it's below the horizontal line. That's a horribly not straight line. The angle of depression is the angle, it goes from a horizontal line downward. So it's coming.
Inside angle of it.
Okay, so the angle of depression is never the one up here in the top of your triangle. People always want to put it there. It's not. So its angle of depression has to be from the horizontal line down. It's the same as what, though?
Complementary.
Yeah. Remember good old alternate interior angles from, so assuming my line was straight, these lines are parallel. So this angle up here, if I call it angle A, it's the same thing as this angle down here. So an angle of depression is the same thing as the angle of elevation down at the bottom.
So A is 18.
So if this is 18 degrees here, then the angle down here at Zeus is 18 degrees as well.
So 72 over there.
You could figure it, you actually don't have to go to that much trouble. As long as you have one angle, you can solve a right triangle problem. How do I need to know then Ernie's height.
You're going to do sine
So you have to go,
We did a whole project over this.
yeah, from the angle you know, we need opposites, and we have adjacent, and so I need to do tangent to solve it. So tangent of 18 degrees equals opposite, which is x, over adjacent, which is 32, and then how do you solve for x? You could use the 72, and then you'd have to do tangent. This is normal. We'll talk about that in just a second. Okay, on your calculators, so we need to type in our calculator 32 times tangent of 18. On your calculators, you have a trig button. Under your trig button are all your trig functions. So we need, actually I should have typed it first. I should have did that. I should have done 32 times, and if you hit your trig button, go get tangent, and punch in 18. As long as all of you set your, you know your angle in your settings is set for degrees. You have to be in degrees to do these. Okay. Yes, I had you set it in degrees the other day. So you should still be in degrees if you haven't changed it. But you would need to check your settings to make sure. If you're getting weird answers, then you're probably in radians. So you're going to hit enter, and there's your answer. Now, this is the one place in math where we use significant digits a lot. And so when you're trying to decide what to round off to, you have to look at how many significant digits were in the original measurements given to you in the problem. Yeah. So we add 2 significants, so you would round this off to 2 significants, which would be 10 even, right? Okay. So we would round this one off to 10 feet. That's great. That or it got piled up, yeah, it got piled up with the tractor. Maybe. Okay, I'm stopping.